All right, guys, we're going to go on and get started with the lesson today. Any questions over the homework assignments? Also, all the Chapter 1 homework assignments are due by the end of the day today. Otherwise, they will be zeros.
So you have to take E and B has to be negative. Negative for B. And then over to parentheses A.
Which one are y'all looking at? Yes.
It's negative 2. Like this. If you put it in this. Negative. Oh yeah, it makes it negative, doesn't it? 2. Yes. 2. So that one, do you think it's all this one? Or is it not one at all? Or did I do it wrong? Yeah, that's really about that. If it's number 22, it's positive 1, and then number 1 is negative. What? Yeah. 22. 23. I know what I meant. Yeah. Okay. I forgot to make it.
You might want to check your Y value for the vertex. Because with 21, because if it is negative 1,
How is it not?
well, no, if you're saying the vertex is negative 1, yes? So if you plug it back in, negative 1 squared would be 1, plus 2 times negative 1 would be negative 2 plus 1.
I'm lost.
Negative 1 squared would be 1. 2 times negative 1 is?
2.
0, because if it was 1, positive 1, 1 squared plus 2 times 1.
Oh, it's because I didn't put negative 1 right here.
Yep.
I put 2 in that spot. I put 2 in that spot too.
All right, guys.
Anyways, back to that.
All right, guys, so the first thing we're talking about today is properties of the x-intercept form. This is the last form of quadratics we're going to be looking at. X-intercept form. Now, the reason we call this the x-intercept form is, well, x minus p and x minus q give us the x-intercepts. It's where it's going to cross the x-axis. Because f of p equals 0 and f of q equals 0, therefore they are the x-intercepts of this function. Are given in the form of p comma 0 and q comma 0. Our axis symmetry is halfway between, so the axis of symmetry is given to us by the equation x equals p plus q over 2. And even though it doesn't have it written here, the vertex is the point p plus q over 2, comma f of p plus q over 2. Guys, Damien, go. No. No, guys. So to find the information we need, we really just need to find the values of p and q, and then calculate p plus q over 2 and f of p plus q over 2. And once we have that, we have everything that we need for these here. So if we look at this example problem, we're given the function f of x equals -2 times x plus 3 times x minus 1. We want to find the x-intercepts, the vertex, and the axis of symmetry. So if we line this up with the general form, our general form is a times x minus p times x minus q. First thing we need to find is the value of p and the value of q. So let's look at that there. So I would agree that p is going to be 3, but it would be negative. Because if we look at the form, x minus p is lining up with x plus 3. The x's line up, and the 3 would line up with the p, but the sign is different. In the general form, it's minus. In the equation, it's plus. The only way we can go from a minus to a plus is if we have another negative involved, because two negatives will make a positive, which means the value of p is indeed -3. And q is 1, because for our x minus q and x minus 1, the x's line up, the minus line up, so q is just 1. Yes? Questions on how we got this here? So really, we're just lining it up, matching up p and q. Another way we can remember it is when we take that number out, we're having to flip the sign. If it's plus inside, it comes out as minus. If it's minus inside, it comes out as plus. Questions on how we got p and q? Okay. Now I'm going to scoot down just a little bit. Because if we want to find the vertex, the general form for the vertex is p plus q over 2, comma, f of p plus q over 2. And the axis of symmetry is x is equal to, well, x is equal to p plus q over 2. So for our vertex and the axis of symmetry, we do need to find out what p plus q over 2 is. I believe so, yes. Questions on anything we've done so far? So the first thing we're finding is p plus q over 2. Well, p is -3. Q is 1. -3 plus 1 over 2. We can do this by hand. We can do it in the calculator. Both will work. Both will get us to the same point. So in the calculator, I can do -3 plus 1 over 2, which is -1. Because -3 plus 1 is indeed -2. When we divide it by 2, we get our -1. Yes. I see what it did. Yeah, it treated it as a positive. So that tells us the x value of the vertex. It also tells us the axis of symmetry, x is equal to -1. So we have the axis of symmetry already, x equals -1. Now to find the f of p plus q over 2, well, this should seem similar to what we did yesterday, our f of -b over 2a. Same exact thing. We just take this value of -1 and plug it back into the function. For us here, it'd be -2 times -1 plus 3 times -1 minus 1. We're just plugging it back in. And again, we could type this whole thing exactly as we see it into the calculator. -2 parentheses, -1 plus 3 times -1 minus 1. And we get 8. . And we have the vertex in the axis of symmetry, yes? And for the ones that we did yesterday, that would be it. But these here wants one more piece of information. We need to find the x-intercepts. And the x-intercepts are t comma 0 and q comma 0. Well, what's the value of p? -3. And then we have 1. So it's the point -3, 0, and 1, 0. Questions on this here? We feel good with this here. For the most part, because once we find P and Q, we plug it into our two formulas, and we have our answers, yes? So again, most of Chapter 2 is really just going to be revolving around formulas. And especially on the test, I just make sure you have those written on the review sheet. Are you ready for the next one? Yes, and I do need to update these note sheets because it'd probably be nice to not have that graph taking up half the note sheet. Might be a little nice. Now, if we look at this here, f of x equals a times x minus p times x minus q, yes? Is that a different formula? What's the nice thing in multiplication? We can multiply any two things in any order, yes? Because 2 times 4 is the same as 4 times 2. X minus p is times x minus q is the same as x minus q times x minus p. I'm showing you this because does it matter which one I pick as p and q? No, I just need p and q. So for this here, and just like the last one, we could say p is what? We could say p is -2. And we can say q is 4. Or I could say p is 4 and q is -2. Doesn't matter which way we have them. They're going to be the same. And even for our two formulas, our p plus q over 2 -2 plus 4 over 2. Would that be the same as 4 plus -2? Yeah, we can add any two things in any order. Doesn't change what it is. Yeah. So really, we just need the value p and q. Doesn't matter which one it is. We're going to get the same answer. Because our -2 plus 4 should give us 2. 2 over 2 is 1. At this point here, the only other calculation we have was taking 1 and plugging it back in. As it was 1 minus 4 times 1 plus 2 is 3. And it might seem a little weird that we started out with a fraction and ended up with none. So our first one, 1 minus 4, is -3, yes? -3 times -1/3. So Our negative 1 times, so 1 minus 4 gave us negative 3. Our negative 3 times negative 1/3. Negative negative makes a positive. 3 times 1/3 is 1. First thing's 1. 1 plus 2 is 3. 3 times 1 is 3. So it worked out nicely. Questions on how we got any of this so far? Vertex is our p plus q over 2, which we found to be 1. F of p plus q over 2 is 3, so the vertex is 1, 3. Our axis of symmetry, x is equal to 1. Int x intercept, p comma 0 and q comma 0. So our p value is negative 2 and 4. So these we're just using the p and q at the top. Yeah. 4 comma 0 and negative 2 comma 0. Doesn't matter the order, as long as we have them both. Questions on this here? Do we need to see another example of one of these? We feel good with these? That's it.